Okay, so in this problem, we're trying to find the z-scores of numbers given a set of normally distributed data. And so we're told that normally distributed data, they're having a mean of 60. So my x bar is 60 and my standard deviation is 8. So my S equals 8. And I want to find the z-score of 68. Now remember, what is a z-score? The whole idea of finding a z-score is we're taking a set of normally distributed data that we found calculationally somewhere. And in order to learn more about that data set, we're going to convert it to the standard normal data, right? We're going to convert it to the standard normal distribution so that we can use more information that has been calculated beforehand. So we can use an integration table so that we can know what our percentage, our percentile of our data is. Basically, how many percent of our distribution falls below the value. And so this is the whole point of finding a z-score, is that that's a very difficult calculation to perform. And by converting our data into this standard normal, we can look that data up rather than having to perform this extremely difficult calculation every time. Okay, well, that standard normal has a mean of 0 and a standard deviation of 1. And so we can memorize the formula. I mean, there's definitely a formula. I'm going to write it here, and I'll provide it on the final, just as I have on our other exams. So it'll be part of that formula sheet for our final. But we can also reason through it and understand it a little better when we realize what we're doing is we're taking the mean away from our data value so that our mean is 0, because our standard normal distribution's mean is 0. And then our standard normal distribution has a standard deviation of 1, and so we need to rescale our data by our standard deviations so that our standard deviation of our rescaled data is 1. And so what I need to do when I'm calculating a z-score, so my z-score is my original data value minus my average, and that removes the mean from my average. And now my data value, if I did that to all of my data values, the average of my data value sample would be 0 because I've subtracted that mean away from all of my data values. Now I need to rescale this thing so that if I calculated the standard deviation of all of my data values, that standard deviation would be 1. Well, I do that by just dividing by the standard deviation of my found distribution. And so this is a formula that lets me take any data value from my data distribution and convert it to the standard normal so that I can compare it with these integration tables from my standard normal distribution and find out how much percentage of my distribution is below this value, which is called a percentile. Okay, so to calculate the z-score of 68, practically all I'm going to do is take 68, subtract 60 from it, and divide it by 8, because 60 is my x bar, 8 is my s, and 68 is the data point that I care about here. And so kind of my z1 here, I'm just using a 1 subscript because it's the first one we've calculated in this problem. And so it's going to be 8 divided by 8, which equals 1. And one thing to kind of notice here is that my z-score, how many standard deviations above the mean is 68? It's 1 standard deviation above the mean. And so my z-score, it turns my data into something where I can quickly see how many standard deviations above or below my mean is, because that's exactly what my z-score tells me, is how many standard deviations above or below my mean I am. Now, in this case, that would have been easy to see by inspection. You could just kind of look at it and say, oh, well, my standard deviation is 8, my mean is 60, so if I've got a value of 68, I don't even need a formula because I know I'm 1 standard deviation above the mean. That means my z-score is 1. Won't always be that simple. Let's take a look at the next problem. Well, the next part of this problem. If I do the same calculation, but for 72, all right, I'm going to call this Z2 just because this is the next one. You could call it ZB, whatever you wanted to subscript that. I'm going to have 72 minus 60 divided by 8. Well, that's going to be 12 divided by 8, which is going to be 1.5, right? Because 12 is 4 more than 8. And so 8 over 8 would be 1, and then 4 over 8 would be a half. So it would be 1.5 or 1.5. You can also do that in your calculator. 12 divided by 8 would give me that 1.5. And so maybe a little bit less obvious, 72 is, if I think about 60, it's 8 and then 4 again, so 12, 1.5 standard deviations higher than my average. Okay, maybe that one was still a little bit too easy to see. Let's try 74. And so if I do my z-score for 74, that's going to be 74 minus 60 divided by 8. And so 14 divided by 8, which will be 7/4 if I want an actual, ratio kind of number for it, or it'll be 1.75 if I want my decimal, right? Because 8/4 would be 2, so I'm a quarter smaller than 2. And so that gives me my 1.75. Now, because I understand z-scores, I know that means I'm 1 3/4 standard deviations above my mean at this point. It's not something that I think we would immediately spot or see or understand intuitively as quickly with a number that's more like the 1.75. Or, again, in these more extreme cases, for these last two parts of this problem, if I do my z4 here, this will be 100 minus 60 over 8. Well, that'll be 40 divided by 8, which is going to be what, 5? If I check that, 40 divided by 8 does give me 5. And so I'm literally 5 standard deviations above my mean. Now, we already know enough about statistics to know that 5 standard deviations above my mean is huge, right? There's a very low percentage of values from my distribution that will be even higher than that. So choosing a value that's that high above my mean means that I'm very much in the tail of my distribution. Okay, let's try 30. Let's see what it does. And so if I do Z5 here, that'll be 30 minus 60 over 8. And so that'll be negative 30 over 8. And what's that going to be? That'll be 15 over 4, right? Negative 15 over 4. 15 is 3 times 5, and 4 is 2 times 2, so that doesn't simplify any further. And so what am I seeing? I'm seeing that is 16 would be 4 squared, right? But that's not 16, that's 15, so it's 1 less than 4 times 4. And so it's going to be 3 3/4, so it's going to be negative 3.75. And if I type that in my calculator, negative 15 divided by 4, I get the same thing, negative 3.75. And again, this is one of those maybe less easy to spot, less obvious z-scores, where I can now know, because I understand what a z-score is, I can know that this value is 3.75 standard deviations below my mean. But I think that would be harder to see if you just looked at the number and the distribution. All right. I hope that helps in calculating a z-score. We'll save actually doing something with that z-score for the next video.